So obviously earthquakes are very dangerous, as we've seen, not just the earthquake itself, but the after effects like tsunamis. So can we predict earthquakes? Well, kind of. We can predict them in the long term, meaning we have an idea of when there's enough stress built up on a boundary that it's inevitable. We have sensors all over the San Andreas kind of measuring the amount of pressure that's building up. And in doing that, we know when one is inevitable, but we can't say that it's going to happen tomorrow at 6 in the morning. Right? So we know when one is inevitable, but we can't say exactly when it's going to happen. However, as you can see here, we can kind of make some maps to assess the risk. And this shouldn't be a big surprise that most of your risk is going to be along a plate boundary. Or here, right, we have our intraplate boundary there. So that long-term prediction, right, well, again, if we know that we are in a seismic zone, odds are we're going to have an earthquake. So what we can do is we can map out where the epicenters have occurred, and that gives us a pretty good idea of where that boundary is and where another earthquake could occur, right? Anywhere along that boundary. What we can also look at is a recurrence interval. So just like we saw with volcanoes, sometimes there is a reoccurrence interval for when earthquakes happen. We see that some zones have kind of a cyclicity with earthquakes, other ones don't. But we can kind of get a good idea just at looking at the evidence, right, of how often these things happen. So we can look at, these are cool, called sand volcanoes, right, sand moving up through these faults and these cracks in the ground. We can look at fault lines. We can look at areas where water has moved from a high area to a low area. So there's a lot of evidence, there's a lot of clues that are left behind that can show us, right, when these earthquakes have occurred. And again, with our long-term predictions, we can take a look at some areas that maybe haven't slipped in a while. This maybe, I hope, looks familiar to you. Here we have South America. Here we have Central America. And you see we've got these big fault lines here. Right, we've got Haiti and all these places down in here. These are fault lines that really haven't moved a lot in the recent past. There are definitely fault lines that are there. It's a plate boundary, but we haven't seen a lot of motion along them. That's telling us that the pressure is doing nothing more than building at that boundary. And that's why when we get earthquakes right in this region, they are particularly dangerous. Like I said, short-term predictions, weeks or months, we're trying to get better about it. Right? We're trying to get an idea about when these things happen. But right, we're still working on it. Sometimes we get little earthquakes that occur beforehand, and they can tell us when they happen. Right, so we can get these things called foreshocks. We can also measure the crustal strain. Sometimes you get, now these are a little bit more unpredictable. You get changes of water in the wells, gases coming out of areas that we don't normally see. This one is always kind of questionable, unusual animal behavior. But there are some precursors sometimes. And interestingly enough, we saw all these precursors in Haiti that show us that something was about to happen.